So today we're going to look at my SV650's headlight problem. We've established that the headlights are extremely dim, especially at night. It's very difficult to see. So there's a number of things that I'm going to check to find out where the problem is and what is causing the dim headlights. And before we get started with a voltage drop test, which should tell us the health of the circuitry, there's a few basic things we want to check. Obviously we want to check that the headlights themselves are clean, that it's not because of dirt, and that's also inside the lenses that we're getting bad performance. We also want to check the bulb and its connections are clean and working correctly, so you might want to replace the bulb before going any further, see if that helps. And thirdly, keep in mind that the reflective surfaces on these lights or in these lights can degrade over time. So your problem may be associated with the hardware of the headlight itself rather than the circuitry. Whether or not that's going to be the problem will remain to be seen. So what we're going to do now is called a voltage drop test. And the voltage drop test basically will tell us how many volts are being lost throughout the bike circuit, so that's the headlight circuit, due to resistance in the circuit, the switches, the wiring, all the various bits of the circuit, and then we'll see what we're able to do about it. So let's get this set up and start with voltage drop test. To do a voltage drop test, you will need a multimeter, or a voltmeter for that matter. A cheap one will do, no need to go crazy in terms of high-spec multimeters. You will also need access to your vehicle's battery, as we will be measuring various points on the battery, and obviously access to whatever point you want to measure in the circuit. So these wires here go to my headlight bulb. I've pulled them out just to make measuring and access easier. Other than that, a few basic tips before we get into a voltage drop test. What you're measuring is the difference in potential between 2 points on one side of the circuit. So if you imagine a circuit, very simple circuit, from a battery to a headlight bulb and then back to ground. One side of that circuit we will call the positive side, and that's from the positive side of the battery to the positive pole of the bulb, and then the negative side is back from the negative side of the battery to the negative side of the bulb. We need to split those two parts of the circuit, and we need to measure them discretely, so separately. And if you measure between 2 points on any one side of the circuit, you should be able to measure the voltage drop between them. First step, however, is to get a reference voltage from the battery. So that's what we'll do now. Step 1 of any voltage drop test is to take a reference measurement of the battery voltage. You will need this to be able to subtract your voltage drop from. So put your multimeter in volts DC mode, in this case 20 volt range, because we should be seeing about 12.5 volts from the battery. Connect your negative lead to the negative pulse of the battery, your positive lead to the positive pulse of the battery, and take a reading. This battery is seeing 12.88 volts, so that's our reference voltage. We should, in theory, have the same voltage as the light bulb, but because of various drops throughout the circuit, due to resistance, due to switches, the length of the wire, the thickness of the wire, that voltage will be dropping at the bulb. So now we need to figure out what the actual voltage drop is in this circuit. So let me just go and write down 12.88 volts as our reference voltage, and then we can start setting up the voltage drop test. So step 2 of the voltage drop test is to decide which side of the circuit you are going to be testing. I will start with the positive side, because the positive side is where, generally speaking, the majority of the voltage drop is going to come from. it is this way because for the power to get to the headlight on the positive side of the circuit, it needs to go from the battery through the fuse box into the ignition switch, from the ignition switch into the headlight switch, and from the headlight switch then across into the high beam low beam select switch, and only from there into the headlight bulb. The ground path, or the negative path, however, goes straight from the bulb to a ground point and via that ground point back to the battery. So much more complex, many more connection switches in the positive side, and that's why I'm going to start with the positive side of this circuit. So what we're going to do is we're going to hook up the negative lead of the multimeter to the positive side of the battery, and we're going to take the positive side, or the positive lead of the multimeter, and probe the positive tang of the bulb when it is on. So it has to be under load for this test to work. So let me just set that up and I'll be right back. Okay, so step 2, I've got the ignition on, got the headlights on, so I'm just going to ground this bulb, and this is the headlight bulb, and we are going to take the positive side of the probe and probe the positive tang on the bulb itself, not the connector but the bulb. And our multimeter will then display the difference in potential between the two sides of the circuit. So it is showing 2.2 volts. So that implies there's a 2.2 volt drop between the battery and the bulb. So from a 12.8 that we had, the positive side of the circuit is dropping to 10.6 volts. Now for 10.6 volts to power a 12 volt headlight, I'm seriously not surprised at all that the headlights are dim. So I think we have found a problem here. Now we're going to do the same test for the negative side, the ground side of the circuit. So I'm just going to switch over the cables of the multimeter attached to the battery, and I'm going to put the negative lead of the multimeter to the negative lead of the battery, and this time we are going to probe the negative side of the battery, and here we're getting 0.7 volt drop. So positive side was 2.5, negative side 0.7. So the negative side, if you take a normal voltage drop to be 0.5 volts, the negative side of the circuit is alright, could have better grounding perhaps, but the 2.2 that we're showing on the positive side implies there is a big problem. So the question is, what are we going to do about that? So now that we've done the test and we've established that the headlight bulb is getting somewhere around 10.6 volts, the question is this a problem, or is this inherent to the design of the bike? I could do the same test across all the positive side of the circuit, measuring between, for example, the battery plus and the fuse box and the on-off switch for the headlights, then off here main low beam high beam switch. I could go probing all of those parts of the circuit to see where the voltage drop is most and see if I could do anything to reduce the voltage drop. However, and this is what's important to remember, if you have suddenly had an issue with dimming headlights, so your headlights were perfect in the past but now they've suddenly become dim, that is what you would want to do. You'd want to go through bit by bit of the circuit to find out where the voltage drop is happening and eliminate the cause of that. So probably is going to be a bad connection, a broken wire or something similar. On this bike, the headlight circuit is complex, as I showed you previously, but more to the point, it's long and the wires are not particularly, in terms of density, copper density, not particularly thick. So what I'm going to do is I'm going to assume that all the component pieces of this circuit are actually fine, that they're working correctly, all the switches are fine, and I'm going to fit a relay to this bike. The point of the relay is to use the current wiring to trigger a low current relay, and then run some high power wires from the battery straight to the headlight, or straight to the relay and then into the headlight, and that way we should have better conductive paths for the volts to go to the headlight, and there should be a significantly less voltage drop at the headlight. So, now that we've established that there is a problem, and there definitely is one, and we know what we're going to do about it, the next step, and that's what I'm going to do in the next video then, is talk about designing the circuit that you want to build. So thank you for watching, and I'll catch up with you next time when we talk about circuit design and how to integrate a circuit with a minimum fuss into your current wiring loom.